Hey guys, and welcome back to a new video. In this video, I will show you how you can implement a global snackbar system that will allow you to show snackbars in your app from anywhere, from ViewModels, from the UI, and these snackbars will also persist across navigation transitions. So we will build a little demo app like here where we can send a snackbar event on the screen. This will actually be sent from the ViewModel, which will then be observed on the screen. We can also do this with customized actionable snackbar events, where we also get a little action which we can click to do something else, which you can also define at the place where we call the snackbar. So for example, from the ViewModel, for example, to retry a network call or so, when you click this retry action on that snackbar. And you can also notice that if we show a snackbar and it's currently visible and we navigate to screen B, then the action or the snackbar will actually persist, same as when we send a snackbar from screen B and then navigate back. So the snackbar will persist, which is not the case with most people's setup. In order to implement that, I already added some dependencies here to our version catalog that we need. Feel free to copy paste these from my GitHub repository down below. But in particular, those are the navigation compose dependency. So to just implement screen transitions as well as defining the routes in the new type safe way with Kotlin serialization. And down here, you can see I just added those two dependencies as well as the compose lifecycle runtime dependency in order to get ViewModel references instead of composables. So let's first set up the most important class in this project for this purpose in order to show snackbars. And that's of course some kind of way that allows us to send snackbars from anywhere. So we need a class that is accessible in all of our other classes. So what we want is we want to go to our root level package, open this here, and create a so-called Snackbar Controller. And that will be an object, so a singleton, which makes sense because we want to be able to access this class from across our project. I still recommend to only show snackbars from your presentation layer, so either the UI directly or from your ViewModels. So ViewModels are in the end the typical place where you want to call these from, but I wouldn't call these directly from a repository, for example, since that does not really have the purpose to decide what is shown on the screen. And the way this class or this object rather will work is like this. We will first of all declare a class called Snackbar Action, which will be an optional instance that we can pass to these events we will then send from the ViewModel to the UI, we can then use to define an action that is shown on the snackbar. And an action on the one hand has a name for the action text, and it has an action lambda, which will be triggered when we click on this action, like on the retry button, on the let's go button that I had in the little sample app. And then we can make use of the snackbar action inside of a new class called Snackbar Event. So this will really be the type of class we will send instances from the ViewModel to our UI, which you can then listen to in the UI to finally show our snackbar. On the one hand, a snackbar has a message, which every snackbar has to have. On the other hand, the action of the snackbar, so the button we can click in order to do something, that is something optional. So we're going to pass our snackbar action, make that nullable and null by default. So it's completely up to us whether we want to show an action with a snackbar or whether we just want to inform the user about something that, for example, went wrong. And then inside of our Snackbar Controller, which will really be the controlling unit for our snackbar events, we will make use of a so-called channel. So we call this events, make that a channel here from Kotlin coroutines, which will consist of snackbar events. And a channel is in the end just a stream between this class and the class where we want to observe these events. And we can just send events into this channel, which you can then listen to in our UI later on. Channels behave very similar as shared flows. I'm deciding for a channel here because a channel is meant to have one subscriber, so just one unit that listens to these snackbar events, while a shared flow, as the name says, is meant to have multiple subscribers. But in this case, since we really want to have global snackbar events, which will only process at a single place at our global UI level, I decided for a channel, since that will also buffer the events by default. So even if there is no active collector, then the channel will keep these in a buffer by default and send these when the subscriber is available again. We will then have a public version of this events channel, which we will expose as a flow. So we say events receive as flow, and then we will have a suspend function that allows us to send a message or send event. That's the best. And here we pass a snackbar event, and we then simply say events.send our event. And this is now the function we can then call in our ViewModel, in our UI, since we of course have access to the Snackbar controller across the project. So this setup will already allow us to send Snackbars from anywhere. But what I still often see people do is that they have a navigation setup that will hide Snackbars, actively showing Snackbars when the user navigates. And the reason for that is that if we take a look in main activity, that the root element in their UI is a nav host. And this nav host then contains multiple screens, and each screen as the root element has a scaffold, which we need in order to show Snackbars, or that at least makes it easier for us. However, that way, every single independent screen has its own independent scaffold, and therefore its own independent layout that can show a Snackbar. And the moment the scaffold is not in our compose hierarchy anymore, which it won't be if we navigate away from the screen, then the Snackbar will also be hidden and dismissed. And in order to solve this problem, we need to reverse this system. So instead of having the nav host as the root element, we want to have our scaffold as the root element, which then wraps our nav host inside here. So here we can now safely have our nav host. We create a nav controller reference, remember nav controller, and then we can construct the nav host in here with the nav controller. We don't need a graph, but just a start destination. And for that, we can just declare 2 sample routes. So on the one hand, a data object for screen A, which needs to be serializable, and a data object for screen B, which is also serializable. And then we can say, okay, our start destination is equal to screen A. We define our 2 composables, so our 2 screen destinations here. On the one hand for screen A, here we get a block of code where we can then put in our compose UI for this screen A. We do the same thing for screen B. So let's now see how we can receive these Snackbar events and also show these Snackbars here in our scaffold. So a little recap, a scaffold is really just a layout, a container for these typical material design elements like a navigation drawer, bottom navigation bar, but also Snackbars, which make showing these very easily and also make sure that these are always shown at the right position. And the first thing we need for that is a so-called Snackbar host state, which is the state we need in order to control the Snackbar. We use this, we construct this with remember and then say Snackbar host state. This is just an empty object we can then use to show Snackbars. Of course, we have to take the state and link it to our scaffold, so the scaffold knows about the state and will also show a Snackbar when we trigger this with the state. We can do this by saying we have a Snackbar host here in our scaffold, which will be a Snackbar host composable, and you can see that takes in this host state reference we declared up there. So this way we already linked our state to the scaffold, but we don't yet tell our state when we want to show a Snackbar. And in order to do that, we of course have to listen to the emissions of this events flow, because whenever we call send event with a given Snackbar event, then this events flow will trigger an emission, which we can then catch in the UI, where we can then finally show the Snackbar. And most people would probably do that like this. They have some kind of a launched effect block here, where they say, okay, Snackbar Controller.events, that they have some kind of launched effect block in here, which just initially triggers, and in there, they refer to Snackbar Controller.events and collect these events in a collect block, where we then get the event reference with every single trigger. And in here, we could then say Snackbar host state, show Snackbar with the information we got in that event. And that will work in most scenarios. But this approach has multiple issues. On the one hand, this is not lifecycle aware. So in a compose UI in an Android environment, we have to take a little bit of care to collect such events in a lifecycle aware manner, so we don't accidentally collect more than we need to when the app is in the background. And very rarely with this approach, it can also happen that such events get lost. For example, when there is currently a screen rotation, the event gets sent or when the activity is in the destroyed state, because in that state, there is no active subscriber of that event. And I've already made a very detailed video about this problem, so I will go over this a bit faster, how the solution for this works. But in case that interests you, then simply search on my channel for one-time events anti-pattern or so, and you will find this video. So instead of this, I'll remove this and go to our root package and create a class called observe as events, or rather just a file, since this will be nothing else than a composable function, which is called observe as events. It will take in a flow reference, so just our events flow in this case, of type T. So I want to make this generic, that it works for any type of event. We can also, pass optional keys. So key 1, of type any, which is null by default. We can pass a second key in case we need that, not in our case, but just in general. And then we will have our onEvent function, which will trigger when we receive an event. And here on the one hand, to make this lifecycle aware, we want to get a reference to our lifecycle owner by saying local lifecycle owner, this one here that's not deprecated, .current. And then inside of a launched effect block, we can pass this lifecycle owner as a key, actually lifecycle owner.lifecycle. So whenever the lifecycle changes, we will recall this launched effect block with a new lifecycle, and we pass our key 1 and key 2. And we might also pass our flow in here, which is not strictly a compose state, but if it was a compose state and it could change, then we better add this as a key. So we would also recall this launched effect block when the flow changes. And in here, we can now say lifecycle owner.lifecycle, actually not lifecycle, but just repeat on lifecycle, which is the Android API to collect flows in a lifecycle aware manner. And here we need to say lifecycle.state.started, so that this block of code will be recalled when the lifecycle is in the state started. So for example, after screen rotation, or just when we boot up the activity the very first time. And if we would now call flow.collect with our onEvent function in here, then this would work in the vast majority of cases. But one thing we have to consider here is that we have to switch the coroutine context to the main immediate dispatcher. This main immediate dispatcher has a special behavior that it just immediately processes such pending tasks that are sent in this main thread. Let's get rid of the issue that events can be lost in the onDestroy state. But again, in this video that I've mentioned before, I really go over this in detail in I think a 20-minute video where you can really understand the problems that the approach could bring if you wouldn't switch to the right dispatcher here. But for now, we can then take this observe as events function, go in here in main activity, call this with our Snackbar Controller.events flow, and then we do get the Snackbar events here. So this block of code now always triggers whenever we send something into our Snackbar controller by using the sendEvent function. We will then also declare a coroutine scope with a remember coroutine scope, which we can then use in here. So we have an independent coroutine for every single snackbar that is shown. We could technically also make this a suspending lambda, since we are also in a suspending context in here, or we could call the show snackbar events, but I want to keep all these independent because then we can easily also dismiss the previous snackbar when we want to show a new one. That's completely up to you if you want that behavior, of course. So whenever we receive a new snackbar event, what we want to do first is we want to dismiss this, as I said. So snackbar host date dot current snackbar data, and we dismiss the current snackbar. And we should, by the way, also pass this snackbar host date here as a key. So we make sure that we properly listen to changes when this changes, which it will never do here, but depending on the setup, it might, of course. And after dismissing the previous snackbar, we can now show our new snackbar with the information we got in this event object. So we can say snackbar host state that show snackbar that takes in a message, where the message is equal to our event.message, so whatever we pass to our event. The action label, which is nullable, is equal to our event.action, and if that exists, we did pass a name to it. And the duration is snackbar duration, short or long, or indefinite, whatever you prefer here. This is something you could, of course, also add to the snackbar event class if you want snackbars with different durations across the app. I will hardcode all these snackbars here to have a long duration. And if we now show an action, then we, of course, also want to respond to clicks on that action. And the way this works is by getting a result from this show snackbar function. You can see that returns a snackbar result, which we can then listen to, because if the result is, or actually is equal to, snackbar result.action performed, then we want to trigger the lambda that we passed to our event class. So event action, which is the actual lambda, and we invoke that if it exists. All right, as a last step, let's quickly create our two screens so we can test this whole thing. On the one hand, screen A, which is a composable screen A, where we might have just a column with 3 buttons. Give this a modifier of our modifier we passed here, dot fill max size, maybe some padding of 16 dp, and we then center everything. Horizontal alignment is alignment center horizontally, and the vertical arrangement will be arrangement.center as well. Inside here, we want to have a button where the first button will just be used to show a snackbar from the screen directly. Just to demonstrate that, here we would just use our Snackbar controller, send an event, and the event is something we can then construct here with all the information we want to use for our Snackbar, such as having a message of hello world. And for this one, we don't want to use an action, so we leave it at null. You can see that is a suspending function, so we also need a coroutine scope in the screen, which we can get with remember coroutine scope. So we can surround this block with our scope.launch, and we are good. The text of this button can then say show Snackbar, and below we can also have another button, actually 2 more buttons, where this one will trigger a Snackbar with an action. For this one, I want to show you how you can trigger this from a view model. So let's quickly create a screen A view model. Screen A view model, which is a view model, and all it has is just a normal function to, let's call it show Snackbar. And here we can then say we launch a coroutine in ViewModel scope, where we also use our Snackbar controller, send an event, where the event is a Snackbar event. The message is hello from ViewModel, and the action in this case is a Snackbar action with the name click me, for example. And then we can define an action in form of a lambda, where we can now define what we want to do when we click on this click me text. So here we might just want to show another Snackbar. So we can again say Snackbar controller, send event, and here we just send a Snackbar without a specific action. So just a Snackbar event with a message, another Snackbar, or let's say action pressed, like this. Here we also need a suspending context, so we could just go ahead to our Snackbar controller and make this action here suspending. Since we are in a suspending context here, thanks to this ViewModel scope coroutine, we can also use a suspend lambda, and then this function here will also just use this ViewModel scope job. Here it can, of course, happen that if you show a Snackbar with a send event function, so the very first Snackbar, and then you navigate away, so the ViewModel scope is cleared, and therefore you also can't launch any more coroutines in this scope, that if you press this action here, that this will never be executed if the user already navigated away. But that is desired behavior, because otherwise you could very easily cause a memory leak here if you would access certain variables or fields from this view model that doesn't exist at that point anymore. But since this function will also be executed in the same coroutine scope, we can't really do anything wrong here, because if the scope is cancelled, then this will never be executed. But in the end, that just makes sense, since if you, for example, have a network call which failed and you have a retry button, then retrying that network call usually only makes sense if you're still on the same screen. Okay, so now we can take this show Snackbar function, go to our screen A, where we might have a ViewModel reference here. ViewModel is of type screen A ViewModel, equal to our ViewModel like this, which we can use to construct this. Let's move our modifier up here so Android Studio doesn't complain. And then we can use this ViewModel reference down here for our button. And we just call ViewModel show Snackbar with action. And for the third button here, we want to navigate to our second screen. So let's do this with a lambda on navigate, for example. Oops, like this, which we then trigger, and then we can react to that in our nav host. So we say we have on navigate here, and the button text says navigate to B. Then back in main activity, we can go down here. We can also pass this inner padding to our nav host so it doesn't complain. Modifier padding, and pass in the inner padding so the scaffold's padding is properly applied to our child and nav host. And in here for screen A, we can then have our screen A, where the navigate function will just call navcontroller.navigate, and we navigate to our screen B. Inside of screen B, let's keep this very simple here and just have a box. I won't add another button here since you got the idea. So we have a box filling the whole size, centering the content, and in here we display a text that says screen B. And of course, inside of screen B, you would have another view model where you also just access this global Snackbar controller. So the concept and the idea behind this really doesn't change. So let's launch this and see what we built. There we go. We have our 3 buttons. First of all, let's try showing a Snackbar from this screen. Yes, we do see our hello world text. If we navigate to B, this Snackbar remains until it is dismissed, whatever kind of duration this this corresponds to, maybe 10 seconds or so. If we go back and we show a snackbar with an action from the ViewModel, then we see hello from the ViewModel. And if we click me, then we see action pressed. So exactly the text that we also defined here in our screen, a ViewModel for our action. And that of course also works if we then navigate to B and then call click me here, then we also see our action pressed, because in this case the ViewModel is still active. It would only be destroyed if we would navigate back, so if the screen is actually popped from the back stack. And with this code, you will now have a consistent approach you can use in all your projects to just show snackbars from anywhere. I know depending on how long you are into Android development, it might be a bit difficult to understand all this coroutine stuff, like the suspending functions, especially this observe as events function to collect these flows and channels in a lifecycle aware manner. If that's a struggle for you, then I have good news for you, because I am working on a very extensive coroutines and flows masterclass, which really deep dives into this topic, teaches you all the internals, all the little traps that you can step into. So if you want to master this topic, then just stay tuned, because the course will launch early September. So thanks for watching. I will see you back in the next video. Have an amazing rest of your week. Bye bye.